Okay, so um, so we've talked about correlations, why they're useful, when they're useful, what their limitations are. Now let's talk about actual experiments. So in an experiment, you're actually going to manipulate um, one variable to see if it causes a change in another variable. Now it's actually possible to infer, although we still always use caution, but at least have stronger evidence of um, causation. Okay. Okay. So there's kind of some concepts and terminology I want you to take away from this section as well. We'll kind of cover those, and then we'll talk about why you can infer causation from an experiment and the assumptions that go into that. So the variable that you manipulate when you're running an experiment is going to be known as the independent variable. I mean, hopefully you're taking notes on all this, but if you're not, definitely write this down. Independent variable is the thing that you manipulate, thing that you change. Does it have an effect on the dependent variable, which is the thing that you measure? So if I wanted to look at whether cell phones cause us to make more driving errors, the independent variable is the thing that I'm manipulating. The dependent variable is the thing that I'm measuring to see if it changes as a result of that independent variable. So I would look at one condition where people look at their cell phones while they drive, one condition where they don't look at they don't have a cell phone, and I count the number of mistakes in both of those conditions. The independent variable there is going to be cell phone use, so either they're using it or they're not using it. And then the dependent variable that I'm measuring to see if it changes based on the thing I'm manipulating is going to be number of mistakes. However, I decide to operationalize that. Okay. We'll keep looking at examples though. So, and of course, the values or the conditions of an independent variable are going to be determined by the researcher. You're going to decide what the conditions are going to be. Okay? So independent means you're the one changing it. Dependent is going to be the subject's responses. So they, whatever you're measuring, whatever that comes out to be, and it's going to be grouped out by condition. Sometimes we'll also call this factor. We actually, I wish we could just all agree on a name, but independent variables can be called conditions, treatments, or groups. But these all, well, actually, they don't mean the same thing, but they mean similar things. You typically refer to the independent variable. So, and just to reiterate again, the way it works is when you have an independent variable, you manipulate it into however many conditions, and then you measure your dependent variable based on those conditions. So you measure how many mistakes people make based on when they had a cell phone, how many mistakes do people make when they didn't have a cell phone. Okay, that's kind of the basic way experiments work. And we'll do more on analysis later, but that's what you need to know for now. So an independent variable can have will always have at least two levels or two conditions or two treatments or two groups. So what do we mean by levels? Well, we mean actually the same thing as these other things. How many conditions or how many treatments or how many groups are there? So, and make sure you remember this because this is very important. So if I wanted to look at cell phones and driving and I had two conditions, then I also have two levels. How many different um, values is the independent variable going to take on? That's what we mean by levels. Okay. So let's say again, yeah, I run cell phones versus no cell phones. That independent variable has 2 levels. Okay. I could add a third and a fourth condition. So maybe I wanted to look at no cell phones, talking on a cell phone, texting on a cell phone. Now I have 3 levels. Okay. So again, levels is the number of conditions, the number of variables that your independent variable can take on. Okay. So, and you can have again, you'll always have, if running an experiment, 2 or more levels. Because if you have only 1 level, well, then it's not a manipulation because it's not changing. You're not comparing 2 or more conditions to each other. Again, I could have 4 conditions or 4 levels, meaning I would have, let's say I wanted to look at no cell phones, talking on a cell phone, texting, or browsing YouTube while driving. Um, then I would have 4 levels or 4 conditions. Okay, so don't forget that. Conditions and treatments and groups largely mean the same thing. The only difference might be that groups kind of implies a between subjects design, but we'll talk more about that later. So don't worry about that for now. For now, just consider these things the same. Okay, so the dependent variable is going to be the thing that you measure in terms of a response. So if I'm again looking at cell phones and driving, I'm manipulating whether they have a cell phone. And my 2 conditions or my 2 groups or treatments are having a cell phone or not having a cell phone. Okay. And those, like we said, the independent variable is going to be determined by the researcher. Conditions are going to be chosen by the researcher. The dependent variable, on the other hand, is determined by the participant's behavior. So this is the thing that we're looking at in terms of a response to the independent variable. And this is also going to be our operational definition, so how we decide to quantify whatever process, thinking, or behavior we're interested in. Okay. So in our cell phone example, this would be, say, the number of mistakes made or the number of stop signs missed. Something more precise is better. And again, we're going to split that up based on conditions. So we're going to separately look for each participant and see how many mistakes or how many stop signs did they miss in this condition and how many stop signs did they miss in this other condition. Okay. That's the dependent variable. Okay. So, and again, we'll keep coming back to this, but whenever there's an independent variable, we're actually manipulating it. Now there's going to be causation because we know that the independent variable is causing the change in the dependent variable, or at least we have good evidence. More on that. Here's another example. Let's say I wanted to look at something known as the bystander effect. This is just when a lot of people are around, you're actually less likely to receive help than if few people are around, because everyone assumes everyone else will be good. If you look like you're lying on the ground bleeding to death in a public place, lots of people walk by, you might actually be less likely to get help than if you're doing the same thing and there's like one person. If I wanted to test that theory, test the idea that having less people around will make it so you're less likely, having less people around mean you're more likely to get help. Well, then, of course, the independent variable there is going to be number of people around. However, you're going to manipulate that. The dependent variable is, say, time to receive help. Okay. Just another thing here, when you make a hypothesis about an experiment as opposed to a correlation, it's actually a little different because now you hypothesize um, what the difference will be, what the mean difference will be. So you say people in this, rather than saying, say, as a correlational design, uh, higher GPA will be associated with higher um, study time the opposite way. You're going to say this condition or this group is going to score higher on the dependent variable than this group, okay, or lower, whichever you pick. So in this example, participants who are with 5 bystanders will take longer to get help than participants with 1 bystander. Okay. So, and again, it should be phrased as a comparison between 2 or more than 2 conditions. So participants in condition A will score higher on the dependent variable, whatever that is, or lower on the dependent variable than will participants in condition B. Participants in condition B will be more likely to show this dependent variable behavior than will participants in condition A. Would be another example. Okay. Okay. So that's kind of what you need to know for now about experimental designs. So don't ever forget about your career here. What's an independent variable? What's a dependent variable? What's manipulated? What's measured? Don't forget those things. That's important, obviously. But let's talk about why we can actually infer causation from an experiment when we can't do that from a correlation. So the 3 criteria, if you remember, were temporal sequencing, covariation, and ruling out other factors. Temporal sequencing being, did the cause come before the effect? It has to for there to be causation, right? Wouldn't make sense to say um, my cat caused my allergies if you had allergies before you got the cat, something along those lines. Remember, covariation just means correlation, so is a change in one variable associated with a change in another variable. That doesn't show causation by itself. And the last one, ruling out other factors. So do experiments, and you have an independent variable that you manipulate, hit these criteria. Well, yes, they hit temporal sequencing, right? You know that whatever you change came before any change in the dependent variable. So if you had people study or do a driving test with a cell phone and then without a cell phone, or even the other way around, and you saw a change in the number of mistakes, there's obviously temporal precedence there, right? You're not relying on pre-existing change or a pre-existing association to just measured variables and not manipulated variables where you don't know which came first or which changed first. So is there covariation? Well, I mean, yes, assuming the experiment, you actually do find a difference. But we've kind of talked about this one already. If there's if changing the cell phone versus no cell phone isn't associated with a difference, 2 things don't covary, then obviously there's no causation, but then there's no correlation either. And then the last one, ruling out other factors. So what else, if we were to manipulate something else, what would it be? Are we manipulating something else? Well, we shouldn't, right? Is everything the same across conditions? Yeah, it should be. That's not the case with any correlation. So again, we don't know if we ran a comparison between wine drinkers and non-wine drinkers and how healthy they are. Well, we don't know about other factors because we basically just relied on something changing in its own environment naturally. We didn't manipulate. Whereas when we manipulate something, we know that everything is the same across conditions except for that thing we manipulate. There might be some individual differences there, but we'll talk about So to kind of compare and contrast, let's say we looked at studying, let's look at cell phones and driving. So if we found just correlational evidence that people who talk on or use their cell phone while they're driving get into more accidents, well, we don't know if everything is equal between people who use their cell phone when they drive versus don't. Are they maybe just more careless drivers in general? And they kind of careless drivers tend to use their cell phone, but it's not the actual cell phone causing the difference there. That could certainly be possible. Bottom line is that because we, just measured something and didn't actually change it ourselves, we don't know whether um, there's other things that are also changing, other third variables that are changing um, with the use of cell phones. However, when we run an experiment, we look at, we actually change whether a person gets a cell phone or doesn't get us. We know then that everything is the same across conditions. Because if we've done the experiment properly, we know that the people who are, or it could be the same person, doing both conditions, they're the same. The two conditions are the same, except for the one thing that we change. Okay. So if nothing else is changing except what we're manipulating, well, then any effect we observe has to be due to our manipulation, right? Just keep that in mind. We'll say that one more time. If we keep everything the same across conditions and only modify, only manipulate one thing, well then that one thing has to be causing the change, right? Nothing else is changing. Okay. Except for compound, and we'll come to that later. Okay, so kind of an application. Does studying emotional words lead to better memory? It does, by the way. What's the independent variable and what are the levels? Well, the independent variable is, again, the thing that we're going to manipulate. So that's going to be word type. We're going to show people either emotional words or neutral words. Okay. And then we're going to measure the number of words they recall. So you can have them study all the words and they write down as memory. So the independent variable, remember, that's the thing we're manipulating. Parameter is changing. That's going to be word type. They either get emotional words or they get, neutral words. What's the dependent variable? What's going to be words recalled? So how many of those words did they actually remember? What might be our hypothesis here? Well, we're going to predict that emotional people are going to remember more emotional words than non-emotional words, the neutral words. Or you could phrase it differently: the condition or the group that gets more emotional words will show more words recalled or better memory. Actually, words recalled is better; it's more specific than those who study neutral words. Okay. And we would have maybe two conditions here, two levels. So either emotional words or neutral words. And again, you can have more than two levels. You could say have positive words, negative words, and neutral words, and more conditions or more levels. Okay. Let's see. Okay, let's stop there for a second.